Hello and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for this video is using ITX with ZLIB BASE64 data. Feel free to reach out to me on popular social media channels at Paul Brett IBM. In this two-part practical demonstration, I'm going to use ITX map adapters and functions to compress and encode a stream of JPEG image data to ZLIB and then ZLIB BASE64, then decode and decompress local ZLIB BASE64 data back to a JPEG file. I'm going to start this demonstration in the ITX Design Studio. As you can see, I have one project called ZLIB BASE64. Within my project I have a type tree called generic.mtt, and if we open that we have a text item which I shall be using throughout this demonstration. Also in this directory we have an input.jpg file, which if we open it is actually a picture of a zip, pun intended. Looking at the map source file we have one map called create ZLIB, and if we open that, the input card is reading my input.jpg file. I have two output cards. Output card 1 uses a put rule to put to the gzip adapter. It uses the file option with a get directory function to ensure that it goes in the same directory as the map, creating a file called output.zlib. The action is compress to ZLIB. The stream, which refers to the incoming stream, is plain, and I'm turning on the trace. Now this is going to put directly to a file, so the card itself writes to a sync. Moving on to card 2, we have a text to BASE64 function where I'm getting the file, output ZLIB, and then the target of the card is writing to output BASE64.zlib. The first card is doing ZLIB for me, and the second card is converting it using the text to BASE64 function. Let's build and run this map and see the results. In my file directory here, you will note that I now have two files, one called output.zlib, which is the ZLIB file, which if I open it, Alt edit, you will notice is a binary file, and a second file called output.base64.zlib, which is after the same data as then being converted with base64. You'll note this is all text, ending with a plus symbol to indicate the end of the data. So how do we know this even works? How do we know this is not complete garbage? So there are two ways to do that. Let's use another map, read ZLIB, to take that data in output.base64.zlib and convert it back to a JPEG to show that it has in fact been compressed correctly. My read ZLIB file. Input card 1 reads output.base64.zlib, created in the previous step. Output card 1 uses a base64 to text function to return this back to the binary text, just ZLIB text there. This is writing to sync because we only need this data temporarily in memory, because output card 2 is reading the contents of output card 1 and using the card gzip adapter to unzip it to a file called output.jpg. Back to the file explorer, you'll note that we don't currently have a file called output.jpg. I'm going to build and run this map. In the file explorer you note that we do now have a file called output.jpg, and if I double click on that you'll note that it's the zip back again. So that proves that the same process is reversible. But there's a second way to prove this. We are going to open a command prompt in the map directory. I'm going to prepend to the path variable the ITX9 directory so that I can run the command server on the create map, and I'm going to do an input echo override. Now that the map has run, if we look at the output.base64.zlib file, you will note that it is much smaller than it was before. We can take this string and copy it into our clipboard and use an online resource to decode this to bring it back to the original string. I'm going to go to an online ZLIB decompressor, and when I paste my string into the top box, it automatically decodes the data bringing back the original that we had. So that is my demonstration of using ITX adapters and functions to compress data to ZLIB BASE64 and decompress back again. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, hit that like button. Perhaps leave me a comment. Consider subscribing to my YouTube channel as I release content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett IBM. Thank you.